Hi, I'm Jimmy Chang, and we're here to discuss the use of the differentials in calculus. Now, differentials are related to the derivative, and the derivative notation you might remember is dy dx is equal to f prime of x. Now, as you know, these two are actually one and the same, but with differentials, you're interested in studying how the change in y is related to the change in x. So oftentimes, to do that, if you multiply both sides by dx, the dx is canceled, and you have dy is equal to f prime of x times dx. So that means the change in y is equal to the rate of change of the function times the change in x. Now, another way in which you can use this is a model that's related to this, but not exactly the same. Delta y is similar to f of x plus delta x times f of x. Now, these are approximations. Delta y is close to f of x plus delta x, which is the difference in x measurements, minus f of x itself. Now, where is this coming from? Now, differentials are used in error approximation because even though you know in theory what the derivative values are going to be, when it comes to the real world out there, you may be asked to measure those in practice, and what you measure physically may not exactly match what the theoretical value is. And so you use differentials in calculus also to talk about error approximation, to figure out how far off you are to the actual value. You want to be as close as possible, but you know you may not always get there 100%. So differentials can be used in error approximation, but also in the rate of change in y as relates to the rate of change in x. So I'm Jimmy Chang, and those are some of the ways that differentials are used in calculus.